for decades, it was easy. You just call your utility, you say, I need a connection, boom, it's there. So why would I bother installing tens and hundreds of millions of dollars of infrastructure to recuperate heat? Now that this is like not the reality anymore, you need people to come together.
Hey, I'm your host, Justin Rice from Climate Tech Canada. Industrial heating is one of the single largest sources of emissions on the planet. And what's wild is most of it, as much as 50%, comes out as waste heat, just gone into the ether. And for decades in Canada, cheap electricity meant nobody really had a reason to do anything about it. Now that's starting to change. Access to electricity is harder to come by, and industrial emitters are looking for power while trying to become more efficient and reduce their emissions. Waste heat recovery is a proven way to solve this problem. You capture heat that would otherwise be wasted and use it to generate electricity, for process heat, or for heating buildings. District energy systems, where whole neighborhoods or industrial parks feed into a shared system, exist across Canada and have for decades. These systems are the ultimate energy efficiency solution, effectively reusing every electron twice. So you'd think we'd have these types of projects everywhere. And they do exist across the country in Toronto and Vancouver and Montreal, but in many countries in Europe, they're everywhere. And what's standing in the way of getting more of these projects done isn't the technology. It's accelerating the pace of projects, getting plants that are located next to each other to actually work together, and optimizing these systems to be as efficient as possible. To explore all this, I'm joined today by Leo Lamy La Liberté and Daniel Bastien, co-founders of Local Energy, a Montreal startup that's working to accelerate complex energy networks. Local Energy speeds up the design and build of local energy networks and uses machine learning to optimize them for maximum efficiency. These local energy networks are popping up more and more, and I wanted to sit down with Leo and Daniel to understand why these projects aren't all over the place already. We talk about what's changed over the last decade or so to drive new interest in these projects, the specific advantages of bringing machine learning to these infrastructure and engineering problems, and why Canada is years behind Europe. And now, my conversation with Leo and Daniel. Leo, Daniel, thanks for joining us today.
Thanks for the invitation.
Thank you. Excited to be here.
Awesome. So lots to cover today. I'm really excited for this conversation. Everything around district energy and thermal networks it's super interesting. It seems kind of an area that's really flown under the radar and is maybe kind of, picking up some momentum lately. So really looking forward to this conversation. Where I'd love to start the conversation though is a bit of background about the two of you. I'd love to hear how you both ended up here working on energy networks.
Yeah, sure. Thanks for this. But I'm more of a technical background. Let's say I've done engineering in university. Did a bit of quantitative finance for a while, and then returned back to grad studies in energy modeling, looking at what we could do in the industrial sector. I was boots on the ground in these industrial companies, and we could look at the whole problem, right? So I was super passionate about the problem, but to be honest, I was not that much of a research hat, let's say. So as soon as we've finished this research project, we've started and pivoted to local energy. So a few months afterwards, I met Daniel, and this is where we are today.
And Danielle, how did you end up here, and like what kind of grabbed you about local energy?
Yeah, sure. My background is really a serial entrepreneur. So this is like my sixth business. I did a lot of the e-commerce boom from the late 90s to mid 2010s. Then I started a consulting firm. I helped a lot of emerging entrepreneurs, always in the tech world. So there's always been a software and innovation side that I did. Then I did some finance, so started two small investment firms. Doing the consulting, it was fun, but I didn't have my hands enough into it. I guess I really need to plunge into it. And I really wanted to do something that tackled climate change, decarbonization, and everything. So then I met Leo. We actually met. I was his mentor at the Cycle Momentum. And then, I was like, okay, decarbonization. Now I see the energy sector. It was all new for me. We worked together for a year or two, and then it's like, all right, let's go. Let's jump into it. Let's do local energy. My background as an entrepreneur, the financial side, the operation side, commercialization side, really is helping to bring this venture on the ground.
Yeah, that's fantastic. We'll dive into what you're building at Local Energy in a second, but I think it'd be really helpful to level set on what we mean when we talk about complex energy systems, district energy, all of these terms. Like, I think it's something that if you were to look around, there's more of these around you than you maybe think. Like, there's systems in Vancouver, Toronto, like all over the place, but it's not something you like see day to day and really encounter. So maybe just catch us up. Like, what is district energy and how do these systems actually work?
Yeah, I mean, great point, and it's like so easy to fall into a rabbit hole and kind of deep dive into all of these specific sectors and very have this kind of engineering lens on. But maybe I could start with a step back on the heating side of things, right? Because 50% of the energy we consume is through heat. So it's basically heating buildings, but most importantly, using heat in the industrial sector, right? This is the single largest source of greenhouse gases globally. It's heating in the industrial sector, right? More than transport, logistics themselves, right? Usually we talk about decarbonizing chemicals, cement, steel, but when we aggregate this and we look at it, like most of the greenhouse gas emissions come from producing heat for these industries, right? So this is where we looking at this bigger scope of things, using heat as a workhorse, working fluid to deliver power, do some action, cook some stuff, or heat some chemicals, right? It's everywhere. So when we talk about these complex energy network, what we mean is there's kind of two verticals there. There's these complex industrial systems, right? You could think of a chemical producing plant, aluminum producing plant, or waste to energy plant burning garbage from a city producing steam or electricity, right? These are all single owner sites that are very industrial, kind of unsexy, but produce most of the stuff that we use today. But then there's this other vertical also, which is more of these thermal energy network, district heating system, when you have a centralized power plant burning fossil fuel or whichever source of heat to share amongst multiple buildings, maybe thousands of buildings, hundreds of buildings, heating a city. When we look at in Denmark, for example, in Europe, some places, 90% of the city is heated through these district heating networks, right? It's pipes in the ground sharing hot water from home to home.
And so when you talk about heat from these industrial systems or power plants, is this all kind of like wasted byproduct or like a byproduct of the kind of core process? Like you're burning waste to generate electricity, or you have an industrial process and just as a result of that, heat is generated, or is this coming from somewhere else?
No, that's right. I mean, it's like intrinsically part of the processes. You are either burning, doing chemical reactions that generate heat. You're, for example, you could have like a big bath of hot liquid metal, and you're trying to melt it in a certain kind of form, right? Well, then this will, when it cools off, it just emits all the heat, all the energy input comes out as output, right? Ultimately, so this is when we start talking about this waste heat. It's a huge problematic. I'll say it's something that we generate 50% of the energy we consume in these sectors comes out as waste heat, right? So it's this white cloud of steam that you see outside of chimneys when you're driving on the road, right? So this waste heat has a lot of energy. It's somewhat hard to capture and it's undervalued today, right? So this is where we come in at Local Energy to try to harness this one.
Got it. Okay. And one of the reasons I find this really interesting is, all of these industrial players who like all of these different actors, they're paying for their energy input. And then they're way like 50% of that just comes out and, goes into the ether, goes into the air, whatever. And it's just like, it's lost. And it seems wildly inefficient. I heard it described as like using electrons twice. And is this the right way to like think about it? Or does that kind of undersell how hard it is to actually do this and capture this energy?
Yeah, I think it's a great way to put it. Like the kind of the value proposition of using waste heat or capturing waste heat and using it again is exactly it. Like reusing these electron twice, or even better, reusing these fossil fuels twice, right? these fossil
Right.
molecule twice, which is even better for the environment ultimately. But yeah, I think this is a great way to put it.
And then, so this seems obvious. You probably don't want to be wasting 50% of your energy inputs. I'd love to get your take on why this isn't everywhere already.
Yeah.
Because it seems quite it seems to make a lot of sense from just like an economic bottom line perspective. But maybe we could unpack, like, what are some of the actual bottlenecks for getting waste heat and district energy projects off the ground?
Yeah. And maybe the first point I want to address here before we go on is it's so easy to point fingers at industrials saying, hey, you have 50% of the energy that comes out as wasted, and it's the largest single source of emission. It's so easy to point them out. However, what I'll say is that this was my point of view before going boots on the ground in these initial plants. But when you go there, you see that these are actually these are the people on the edge of decarbonization. These industrial facilities are already at like almost maximum efficiency. They're so well oiled in a sense, so well they're very efficient in the way they do processes because it's millions of dollars for them, right? So and they have the will, let's say, to change. They're the one pushing for better policies, right? To have these kind of these action and policy put in place so that they could be support on the financial perspective to decarbonize, right? So this is kind of just painting the whole painting there first, but there's two things with waste heat. It's hard to capture because usually you need capex intensive solutions, right? Whether it's heat exchanger, you need to do something with this waste heat. And the hard part is you compare this with just simply burning more fossil fuel or using more electricity. It's hard to get a good ROI case, right? It's starting to change now that we don't have any electricity at our disposal, or like we're getting more constraint in that sector. So that's a big tailwind. But this is kind of the first hard part, right? And the other one that we are looking at ourselves at Local Energy is that all the obvious heat recovery projects, the obvious projects are already done. Whether it's about talking about heat exchanger, thermal storage, batteries, etc. They're where it makes sense, they're built, right? But today, what we believe is the gains are not inside a single machine. They're in the way you orchestrate them as a whole, as a system of system in a way, right? So let's say you can predict there's going to be a huge increase in energy demand coming up tomorrow based on your processes, historical data, whatsoever. You could preheat the system, prepare it to take into account this peak in production, right? Without being inefficient or becoming reactive, right? So by being able to become predictive in that matter, you're able to lower the energy consumption of every system without having to install new capex, right? This is the big value that we see is efficiency comes from orchestration and not simply new capex build out.
Yeah, and maybe if I can add is that why aren't they everywhere already? Was your question? Is there's a big part of history that is linked to Canada because energy was very easily available for a very low price. So if you go, I know we're probably going to talk about other markets later, but for decades it was easy. You just call your utility, you say I need a connection, boom, it's there. So why would I bother installing tens and hundreds of millions of dollars of infrastructure to recuperate heat when I can just make a call and then I get my hydroelectricity plugged in? So this is a large reason why energy was too available, too cheap, and it made it not motivating enough to look into project to recover heat. And now that this is, like Leo said, not the reality anymore, you need people to come together. So it's not really the technology aspect, the recovery aspect is not the challenge. The challenge is to get everybody together, to coordinate everybody, and to plan it from the get-go is actually quite complex.
Right.
And we actually tackled that as well. But the complexity to tackle it, the coordination of it all, is what is making a slow progress into these projects at this time.
Got it. So there's a couple of pieces there. One, historically, electricity and energy in Canada has been pretty abundant. There hasn't been a need to seek out these efficiency improvements, particularly with high capital costs in installing this equipment. I think this is a good segue into how you're solving this at Local Energy. You're tackling this to the two sides of it. There's the builder side and the operator side. And I think, Daniel, you kind of spoke to both of those pieces. There's like the upfront planning of, do we have everyone in the system talking to each other? Do we have the right people? As well as, is that actually being coordinated effectively? So maybe just talk us through those two angles and how you're solving those challenges.
So when we work with our platform is it's about working from A to Z on these projects, whether it's about supporting stakeholders or um, project developers or investors in these projects. We use our builder tool, which is our specialized optimization software, that allows us to kind of design the optimal grid or the optimal energy networks. We can think of like storage system, for example, but the size of pipes that you need to put on the ground, but also the cost involved, right? So it's about using these new software approaches to support these complex projects so that stakeholders can rapidly kind of decide if there's a go no go decision or do some projects finance on the whole thing, and then approach these clients and say, okay, let's build out this project together. Here's where the financial makes sense, here's where the technical makes sense. And it's about supporting the decision making from the get-go, right? Having a software approach on this one rather than a traditional engineering approach allows us to kind of become a bit more flexible when data is not present, right? So when it's all greenfield projects, there's no operational data. We're able to do sensitivity analysis, and this is the nerd in me speaking out right now. But I believe that software in that case, when it's a low quality data environment, kind of supports this decision making better than using Excel and doing scenarios analysis, which is what we do is what we see in the market. But then let's move on to as we get closer and to the operational side of things. In brownfield projects, even we could deploy our second solution called the operator on existing projects, right? So you have multiple industrial companies connected together through pipes exchanging steam on a daily basis, or even a district heating system powering a whole city, or a single waste to energy plant burning the waste that we've talked earlier and producing steam. We could deploy our operator there, simply look and listen at the live data coming in from all the sensors that they already have in place, and then predict the future state of the system through machine learning. And then we're able to take, once we've predicted the future state and simulated 10,000 scenarios, we're able to operate and identify the value levers directly, which basically means it's a bunch of complexity just to say that we're able to predict the future state of the energy network and say, well, you should open or close this valve a little bit more, or you should send energy to this client rather than the other one to maximize the value of everyone, right? So it's you could see this as having this kind of co-pilot always looking at the system saying, hey, here's what you should do in a predictive manner. Another case example would be the energy prices. Usually they fluctuate drastically over days. If there's a huge cold in Quebec, for example, Hydro-Quebec will spike up the prices for a few hours, right? So by having this AI co-pilot always listening and being ready, saying, hey, tomorrow we believe there's going to be this huge spike in the electricity price, we're able to kind of send signals to the human operator of the industrial company and say, here's how you should work out your system. Here's how you should operate your system, given the fact that tomorrow is going to be a much pricier setup, right? And
Right.
different. And Daniel came up with this analogy, which I really like about what we do. Is it's kind of this Waze and Google Maps analogy, right? Beforehand, when you wanted to drive somewhere, you would use these paper maps, right? And you had this old static information, and you were planning your route. But with AI and real-time data, once they came in, we are now able to have Google Maps kind of reroute your trajectory at the moment traffic conditions change, right? I feel like this is a beautiful parallel to just kind of changing the trajectory of the way you operate your system.
And so I guess like the alternative is kind of both on the build and operate side is spreadsheets. I would imagine you maybe can figure out a couple of different scenarios to model, but largely, we'll just like map out what has happened and project that into the future. Whereas it seems like what you're talking about is a lot more running more scenarios and in closer to real time, less based off of, October last year and what that looked like. We'll plan for that again.
Yeah, exactly. It's like where do you start if you only have Excel in front of you and this $150 million project in front? What are you going to model, right? So, yeah, having these specialized software helps. So I'm trying to recall, Daniel, but I feel like one of the projects that we did, we had 32 million parameters taken into account, right? It would take weeks for my personal computer to
Wow.
just find the solution, and then we run it 20,000 times because we have these super clusters and efficient models, right? So this is kind of the power of software in these projects.
Yeah, and the reality is that we have our solution, which is actually very complementary to what exists nowadays. So traditional engineering is there to make sure that the system work. They don't break.
Right, right.
They
Okay.
have control variables, and we actually really want that. What we bring is the layer that really optimizes it and says, look, on a normal day, this is the route, but today we have maintenance there. We have a broken equipment there. We have a demand, a peak demand that is incoming. So all those variables that come in in real time, this is where our AI machine learning side is complementary to make sure to see, okay, even given the normal control system to make sure that it works, we can actually deviate, take this angle, take this approach, warm up the boilers earlier so that we really, are more efficient with our energy. So that's what we bring in, I guess, a 2026 energy management system, right?
Yeah, yeah, absolutely. Yeah, kind of bringing it into the current century. What is the impact of this actually convert into? Like, is this a 5% efficiency, or is this like cut a month off of the build time? Like, in maybe I don't know if there's like projects we could talk about, but like, what is the concrete impact of deploying a local energy solution versus kind of how this has been done in the past?
It's a bit harder to quantify with the builder tool, right? It's like we accelerate these projects, we are building more robust project. But what I'll say is that, like, our North Star metric is we are actually allowing for more ambitious projects. We have some tremendously high ambitions for our energy transition. We need to build these complex projects, right? And it's not with the methods of yesterday that we'll do it, right? We'll build the project of tomorrow with the new tools needed, right? And we need those tools. So this is for us the biggest impact of the builder is it allows us to build out these way more complex projects in a matter that's mature still, right? And not based on rule of thumbs, right?
Right. So you maybe go from like 2 actors to 15, and all of a sudden that
Yeah,
becomes possible.
exactly. Or what
Cool.
we see usually is let's look at the industrial use case when a like an industrial plant will share its waste heat with a neighboring plant, right? It's right across the road. Like, it's been
Mm,
happening for 25 years. They know each other very well. But they don't do it. They don't do these projects because there's so much uncertainty. It's like how much it's going to cost, what happens if there's a price surge, or and just having these software to answer these answers for them kind of solves the issue of like uncertainty, and it's one of the biggest factors. And then now if we look at the impact of the operator, this is where it's a little bit easier to quantify, right? So there's the greenhouse impact, right? The greenhouse gases impact for us, it's tremendous. We've been audited in the past, and for a single industrial park, exchanging waste heat between each other, right? Replacing natural gas or fossil fuel steam that's usually there. This is 10 million tons of CO2 emissions avoided on a 20-year basis. This is like 2.5 million cars off the road like this,
right. Yeah.
which is it's hard to even grasp at the benefits, right? These industrial companies have the numbers are so big, it's hard to grasp. So a little bit of efficiency here and there has a tremendous impact. And on the economic side of things, it's tremendous for these companies. It's energy is the biggest expense that they have usually, or top of some of the biggest expense. So meaning a single operator projects could save in the high six to seven figures in benefits for them yearly.
That's significant. It also seems like, and we'll talk about this a little bit later, but it seems like it starts becoming almost like a strategic advantage at that point to be able to do these projects, similar to how you would want to site your industrial plant where there is abundant, energy or electricity. You'd also probably want to look at yeah, where can I tap into one of these systems so that, this becomes X times more efficient? It'd be helpful to maybe wrap our head around like the size of this opportunity. Is it a handful of sites around the world, or is this kind of like, hey, we could probably start roping in a lot of different players here?
It's actually surprising. So everything heat recovery is a lot more advanced in places where electricity was not so cheap. So in Europe, there are networks in every city. Here in Canada, we are connected on one network here in Montreal. There's two or three more active. There is, I would say, anywhere between 10 to 20 large heat recovery network from a municipal standpoint, but it's really gaining traction. And there's also, this is more in terms of the district heating sector, but every one of them is huge. And that's without including the thermal energy networks on the industrial side. So then you can count a few hundreds industrial parks in Canada, and you have hundreds of opportunity in Canada that can make an impact. Like Leo was saying, one industrial park we modeled is 70 megawatt. It's huge in terms of that's in megawatt, but in terms of GHG avoided emissions, it's gigantic. So we don't need to do 10,000 projects like this. It counts in the hundreds and the maybe 1,000, but that's where we would have huge impact. And the opportunity is big, both on the energy side and the decarbonization space. Just looking at this, just in Canada, we can expand, but worldwide, everybody is moving towards that as well. There's organizations that are gaining traction. So I think it's something that will be part of the energy landscape for the decades and the hundreds of years to come.
Do you have a sense on the emissions side what the impact look like? I would imagine it depends a lot on like the fuel source and like some of the site specific details. But Leo, you mentioned like the 10 million tons, but do you have like a rough heuristic of like, hey, for every site we're expecting in the ballpark of, X megatons of emissions? Must be so hard
it's
to
hard.
like break down.
No, I mean it's hard because it's so dependent on the jurisdiction, right? So in Quebec,
Yeah.
power comes from green, almost fossil-free electricity. If you look at some places in the States, you get 60% super high density fossil fuel in the electricity mix, right? So it really depends on where you're at. What I'll say though is that we can talk in numbers on energy efficiency side of things, right? So industry benchmark is 7 to 12% energy efficiency for every kind of software deployed and in these spaces, right?
Okay.
We believe that with machine learning, we're able to go a little bit beyond that. And this is what we see from our first few deployments, is that we could go all the way up to 15, 17% efficiency. But then highly depends on the projects. And I don't want to get too far ahead of myself here.
Yeah. No, that makes sense. And Daniel, something you mentioned there about the municipal projects. I remember I saw a little while ago there was a presentation from someone. I think it was maybe the city of Vancouver's like neighborhood energy, and it was interesting seeing they did their first site and kind of proved it out, and then a couple years later they showed a wider map, and all of these other regions around that project had started to investigate or build out these heat recovery or district energy systems. And it seems like one of those things that kind of like it takes a village, like to see it proved out and say like, okay, we can do that too. But also, getting more of these multi-site projects off the ground, like it takes a lot of people to make that happen. I'd love to hear like who do you tend to work with? Because there's folks like Creative Energy or Corix here in Canada that are maybe doing some like laying the actual pipe. I think that's another thing that maybe people don't appreciate is like you have to like dig trenches and put down pipe. But yeah, who do you tend to partner with in these projects, and like how do you bring people to the table to get something like this off the ground?
It goes back to one of the challenge that we mentioned earlier, where collaboration and who is the main stakeholder that takes the lead. It is part of the challenge, but I would say that this challenge is becoming more clear, and people want to take the lead. So our discussions are with generally with the big infrastructure developers. So you mentioned Corix. Then there's here in Quebec, there's Énergie. There's
Right.
Equans is working on some, especially we were at the IDEA conference about district energy
Yep.
a few weeks ago, and they just launched a few thermal energy network in the Ottawa region. They also
Right.
operate another one that's known in Richmond in BC. Um, so it's those type of big infrastructure company, but then there are some district heating companies like Enwave, for example, in Toronto, that want to take the ownership, the stakeholder, and they want to bring in the best solution to operate them. So it's those type of infrastructure company that are trying to take the lead. On the flip side, you mentioned Vancouver, and the municipalities are starting to do called projects, right? To all right, define which zone I can do, which how can I do a thermal energy network, or so we see more proposition call for proposition to develop those things. So it's clear from our standpoint that we will see a lot more projects like that coming along. In Montreal, we're working one client here, but there is a district heating network in Montreal run by Énergir. It's all public and people don't realize it, but it's been operating since the 60s, I believe, and it's
Wow.
close to 350 megawatt, and it powers from the biggest tower, Place du Marie, to de la Commune, and it just runs on a plant. So
Right.
it's people don't realize it, but it's already part of our lives, and it's expanding, and it's something that can really complement and bring a lot of services to the overall energy network. So I think it's great. It's gonna move forward, and so it's who we work with, the big infrastructure developers.
Yeah, yeah. No, that's really interesting. Seems like such an impactful role for those municipalities to play too, as a coordination point, setting up public infrastructure that has all these knock-on benefits. It stood out to me as something that, if you're trying to attract investment to, let's say, like an energy intensive industry, to say like, hey, we have existing infrastructure that you can plug into and kind of build off of. It seems like a pretty strong selling point. I wanted to circle back to the data side of this. Obviously, this is a critical piece. You mentioned like understanding like should I open this valve and the millions of parameters that you're running against. I would imagine you're dealing with a wide range of data quality. Let's say that everything from like clean live APIs to Excel sheets that are like missing days of data. What does the data side of this look like, and how much of this like is just like a data cleaning problem versus hey, we can take some use the LLMs to kind of work around that.
Well, that's a great point. It's actually cleaner than you thought, right?
Okay.
Industrial companies, they already run their plants with data. Like they're data driven. Some of them are not like Industry 4.0 yet, but they still have these well structured data flows that are live, right? So as soon as you find a way to tap in these data structure without breaking everything, you get a vast amount of data, a rich amount of data. Where we use AI is less in the LLM space and AI agents and generative AI that we hear about so often. It's more in the machine learning space, right? So usually to kind of do energy efficiency projects, you need to be a first principled engineer, let's say, and you kind of write down the thermodynamics equation of heat loss through a pipe, and you try to model everything, and you make sure that you're trying to have like thousands of equations for how this industrial plant is running and trying to make sense of it. But with machine learning, we're able to, well, the machine, the machine learning is able to get a grasp of the function and the relationship between all these valves without needing any equations, physical equations, right? So when you have a rich enough amount of data, you're able to do this without becoming first principle kind of constraint in the way you model the plant, and it just shrinks the time to deploy these solutions by such a vast amount, right? And the other thing I'll say is that it allows us to add more data in it, right? One of the projects that we've had was this waste to energy plant, and the goal of these projects was like they burn waste, they produce steam, and then they sell this steam to neighboring plants, right? So that's simple. However, there's like thousands of parameters in it, and you check that the goal of this, like the value, the most value extracted is when you're able to predict the amount of steam that they'll produce in the next hour, the next week, for example. And they've been trying, like the team has been trying to do this for years, right? And it was so hard because it's dependent on the amount of waste and the quality of the waste that they burn, right? And by using a machine learning approach, we figured out that weather had a huge impact on it, right? And then the team was like, yeah, we know weather is impacted in this, but it's like, yeah, no, but now we don't have the equation for the weather, but we know for certain that it was the previous 2 weeks of weather that had impact because people in the streets were leaving their garbage bags open, so the rain would fall into the garbage bag, and then the waste would be wet, and then it would
Right.
produce less steam, right? So it's almost impossible to map these relationships by equations, but machine learning, we were able to identify that it's like people actually leaving their bins open. That
That's
made a
wild.
huge impact on the amount of steam produced, right? So this is I feel like it's a good example to showcase the power of ML.
Yeah, yeah, absolutely. I think that's the knock-on effect from something you'd never think about is going to impact your system. I think we should unpack that distinction you made though between Gen AI and kind of some of the like current models that are coming out and how you folks are approaching it. And I know you have like the partnership with Mila, Quebec's AI Institute. Maybe just talk a little bit about the distinction between how you're deploying AI in local energy. I think we were talking earlier about like responsible AI and like kind of what that means in this application.
We are greatly proud and fortunate to be a Mila partner. So Mila is this AI institute in Quebec. It was founded by Yoshua Bengio. So we are surrounded. We are in the building. So we are surrounded by scientists who, what they do day in day out is the latest model of AI and machine learning. So it really helps us to have a cutting edge view on which model to use, which technique to use. What allows us to do automation from a machine learning and AI point of view, and to do what we refer to as traditional AI. So it's not Gen AI. So we build a model per client, per project, but we're able to automate the deployment so that it's easy and it's faster, and this is really creates an advantage because we start to understand the system very quickly, the project of our clients very quickly, with a great segregation between all clients. You know, it's important that we keep things very secure. We have a big emphasis on obviously cybersecurity and everything. So we're really traditional AI where our models are site specific, project specific. So yes, it uses compute power, but it's nothing nowhere close to Gen AI. So
Right.
Gen AI has this reputation that we need to build a data center at every corner so that we can, create cat videos.
Right, right.
And I mean, it's Gen AI, and we do a lot of other things with it. I'm joking, but we don't use this compute power this way because it's very localized. But
Mm,
so it allows us to use AI to produce efficiencies that really outrank what we use as power to create our results. So all of this makes it that we're in an environment where Leo mentioned it a little bit. We're able to model the client's site very quickly, very efficiently, and to bring efficiency using AI. And again, our head of AI, Simon, is from Mila. He's finishing his PhD. It really gives us an edge, I think. And I guess the last thing I would say on this is that AI can be, I guess, scary, and people think of it as a black box. But it's really ML on our side. It's really ML models, and we take great pride in doing it the right way. So, we separate client per client. We make sure that we have processes that are sound. Both our head of AI and myself are, certified, if you will, in responsible AI. So there is such a way on how we handle the data at the beginning, at the end, how you do tests to make sure that we do things properly, and it's
right.
something that we care about. It's not a black box. We take it seriously.
Yeah.
This is the ecosystem that we live in. And we really want to bring this to our, I guess, market, which is the energy market.
Got it. And how do you think, like, was this it seems like this was an intentional decision. And how do you think about, like, I hear folks saying, like, well, the solution for a lot of this stuff is just like throw more compute power at it, like more powerful models, more compute, and we'll get the energy efficiency improvements will just keep coming. Like, how do you think about that viewpoint?
It's a great question, and you'd be surprised of how often we get this question here at Mila.
I
Like
bet,
people,
yeah.
all the students are they're like, it's a polarizing question. Like
Hmm.
half of the students are like, let's put more power, we'll get more intelligent model, and AGI is going to come in, and the other side are saying like, well, no, we need like a complete shift in the way we see things, right? Um, maybe a view on this second point is these world models, right, which is becoming a new, not a new trend because they've been here for a while, but a new perspective, like applied AI, physical AI is kind of the words that are coming in, which are not just chat GPT prompts. Like you wouldn't want to have a energy forecast based on a prompt that you've asked chat GPT, and you can ask the same prompt tomorrow and you'll get a different answer, right? So having these kind of applied AI or world models, they're kind of a way to use AI to get a good grasp, a good understanding of reality, right? And it's much more deterministic than just kind of pitching in the world of these ChatGPT and LLMs an answer.
That makes a lot of sense. And if you're relying on this for operational decisions, you probably want some matter of determinism and reliability there. Yeah.
Exactly.
Yeah. Cool. Well, I'd love to shift gears a little bit and kind of zoom out. And Daniel, you kind of hinted at this a little bit, but I'd love to talk about where Canada stacks up internationally when it comes to waste heat and district energy. It seems like, we talked about Vancouver and some work happening in Quebec and Enwave and all of that. So there's pockets of progress. And honestly, more than I thought, like before I started digging into this, it is kind of this invisible infrastructure layer. But it really does seem like we're still far behind some places in Europe specifically, where there's been more done to kind of like build this out. Maybe just talk us through, like, what are some of the jurisdictions that are getting this right, and like what's making them successful? Like, what are some of the ingredients that's really made this take off there?
Uh, yeah, I think it's once we start to compare, we see the work that we have ahead of us, and I would say that yeah, we're very behind. Okay, so we did go to trade shows in Germany, and we traveled to Denmark, and we saw partners in the UK. So we went to see on the ground what it was like. Uh, the number one uh, the number one fun fact that Leo keeps saying is that he went to Denmark and he's like, all right, here's my presentation. Here's what I'm going to do. And the 15-page deck that we normally use here to explain the context of what is a district energy network and blah, blah, blah.
Yeah,
They're like,
yeah.
no, we know all of this within 5 minutes, jump to page 12. So over there, it's normal. Here, we still have to educate a lot of people, although I would say I see a shift in the last in the last year or two. So a lot more advanced. In Denmark, for example, and all the Nordic countries, district heating can supply about 65% of buildings, you know, right
Okay.
away.
Yeah.
Here, I talked about one network that spanned an area of 2 kilometers. Over there, it's 65% of buildings. In Germany, they just passed a law where if you build or develop a community, you have to have district heating. It's
Okay.
in zoning, it's in the bylaws, it's in the urbanism, and people don't question it. It's normal. Here, you still have to sell the project, get the people motivated, figure out how it's going to work financially. So it's a long road ahead, and we are behind. So, but it's moving forward. It's moving forward. And there are people in Europe that are now interested in coming to do projects here because they see us as, a land of opportunities.
Yeah, yeah.
We work with the infrastructure fund in the UK that they already run about 30 sites like this. One fund, 30 sites, uh, and they want to come to Canada to develop it. So I would say it's important that we tackle this. It's important that we see the the entire potential. It's the largest untapped source of energy that we have that can contribute to decarbonization at the same time. So we're opening our eyes. We're moving in that direction. I think there's a lot to learn from other jurisdiction. From conversation we've had with both the government of Quebec and Canada, uh, we see that policies are shaping up. So it's a good
Okay.
thing. We encourage it, and I think it's gonna be part of the mainstream conversation within 1 to 5 years. Hopefully,
Okay.
let's give it a chance.
And I don't think I'd be true to myself. Look, I'm a passionate skier, right? And when I went to Denmark, there is this project called Copenhagen, right? Which I need to talk about right now. I encourage everyone to go and look for this project. It's a waste to energy plant in Copenhagen, which burns waste and powers like a massive amount of the city heating through this. But the one thing is that it's a beautiful industrial building with a ski slope on top, right? So you ride the elevator in the incinerator plant, and then when you come up top, you can rent some skis and ski down the hill, right? So it just like it's a beautiful, I don't know, analogy in a sense to say like I feel like they've got things right, right? It's
Yeah, yeah.
integrated with the city. They know about it. It's nice to it's fun to go and see it, but you also kind of learn about the way to power or heat your home right through this system.
Yeah, yeah.
It's a good one. And to finish this parallel, we are starting to see project of this magnitude, I think, or this thought process here in Canada. The one that was done in the Ottawa region called ESAP.
Okay.
Uh,
Is that
that
around Parliament Hill?
It's on Parliament Hill,
Yeah.
right by the Supreme Court, I believe. They built it alongside this river. They built it in the rocks. They designed the side so that it looks like the rocks are still there. On top of it, they built a nice park where you can walk, sit, go enjoy nature. And they made there's still two chimneys, but they designed it in a way that it looks modern. So it just opened up, and they did look at everything that was done, including Copenhagen, to get inspiration. Uh,
Hmm.
we're going in the right direction.
Yeah, for sure. No, I think that that project is maybe a 20-minute walk from my place, and I've seen it on the other side of the river, and you'd think it was like a modern art installation or something like that. It does not look
Right.
like an energy plant or infrastructure or anything like that. So it's good to hear that there's moves being made. If you were to look at the Canadian context, and we can talk about federally or even in at the provincial level, are there specific things that you would like to see to really move things along and kind of accelerate that pace, whether it's, I don't know if it's policy or capital, if there's some other aspect of it, but yeah, where do we need to kind of do to get the ball rolling a little bit faster?
Yeah, maybe there's two things, right? From what we hear in working with these partner of us that Daniel mentioned before, like capital's there. If the project makes sense, the capital will be there and they'll happily deploy it, right? There's even international funds coming into Canada trying to figure
Yeah.
out a way to deploy the capital, right? So I don't think that's a huge issue. However, I'll say is that we need kind of some innovative policy to support these projects, right? So I'm just speaking from the Quebec lens here, but we have some energy policies um, are a bit old in the way we see things, right? We need to have kind of these more dynamic energy prices, more connected with the reality of the grid, right? And as soon as we see this, we'll see a better price of energy that will reflect kind of the energy demand, and I'll just support even better the financial benefits of having a district heating system, right? These huge system with hot water in them, you could almost look at them as a huge battery, right? But it's not valued today simply because the electricity price is super static, right? But if you
Interesting.
make it a little bit more dynamic, a little bit more dependent on the demand, then you start to leverage some even greater benefits in these thermal system, which are kind of overlooked right now with some more static prices. And this is when we say like Europe is a little bit ahead of us. This is the reason. I think the main reason is the prices of electricity in Europe are very flexible. So in order to harness all the potential benefits of these thermal system, I mean, just let's jump into this flexibility part of things.
Yeah, I would add that policies from the government will also have a big impact. Just to make sure that people are motivated and everybody is going the same direction. I think that the capital is there. There's a lot of people who are interested in putting money into energy generation and decarbonization. I think that the knowledge, the physical knowledge, it exists. Um, the getting everybody together, getting it happen, making it happen is where encouragement is needed, and policies would go a long way.
And looking at some of the those European examples, a lot of it seems to be giving municipalities like the ability to require this stuff. And I think too, it's an interesting point about just a more flexible understanding of energy. Like we don't need higher energy prices for this to like pencil out. We just need to like value it properly and like in all of its different forms. I think too, it's an interesting time like this. If we zoom out, this checks a lot of energy security boxes in terms of reducing the overall energy demand. This is big infrastructure projects. Like there's a lot of boxes that this checks, I think, in terms of where Canada's energy strategy is going, the electricity strategy, and all that kind of stuff. That's largely been focused on energy generation. I think this is a great complement to some of that and thinking about, end use of energy and kind of setting ourselves up to be more efficient with our energy use as well.
Yeah, that's right. And that's what we see in Europe. Like, I don't want to butcher this, but in Europe, they've just passed a huge policy stating the fact that there are subsidies available if you want to build out some new thermal capacity or new production capacity or energy capacity. But the one thing is, if you want to receive the full subsidy amount, you need to take into account these flexibility solutions, right?
Right.
So it's about thinking as a system and not just producing more static capacity at one point for the next 25 to 50 years. It's about just how does it fit with the rest of the system, right? So I think it's a beautiful inspiration for us.
Yeah, perfect. We'll just maybe end off with one final thought. So if everything goes right, what does local energy look like in 10 years, and how does our energy system look different?
In 10 years, and how does it look different? It's a big question. It's a vision question. I think that in 10 years, we're definitely local energy. Our innovative software solutions, we are targeting district heating, so municipal project. We are targeting really the industrial side. So there is a huge gain to have in terms of energy, but the genesis of all of this for Leo and I was really decarbonization. We have to present it becomes presented as an energy solution, which it is, but the real benefit at some point is we want to help and support climate change. So we want to be able to help the industrial side to reduce the GHG emissions. And there's Canada, there's Europe, eventually the United States, once it may be a bit more stable. But we want to have our solution bring energy efficiency and have a big impact on demand side management to lower peak of energy. So we really want to be able to reduce emissions, and it will be counted in the millions of tons. So this is where we're going to be. It's going to be on at least hundreds, if not thousands of sites. And our solution, we think, can really bring this in terms of bringing good impact on the problem that everybody's should be fighting.
Yeah, I mean, that's a great way to put it. I can only support it. Looking at the increased speed of deployment on our side, being only software, like it's very believable. And I'm a dreamer at heart, but I struggle to kind of give myself a bearish assessment of not being on 10,000 sites in 10 years. Like it's just going to become exponentially fast to deploy these projects. So might as well just deploy on all the thousands of industrial sites that we have in Canada, and expand elsewhere.
Yeah, love it. Awesome. Well, Danielle, Leo, thanks so much for joining me. This was a really fascinating conversation. And where can people go to learn more about local energy and get in touch?
Sure. You can simply go on localenergy.ai. It's our website. Leo and I are easily found. We can find us on LinkedIn. Otherwise, Leo at localenergy.ai, Daniel at localenergy.ai.
Perfect.
Don't hesitate to reach out, and we'll be happy to discuss decarbonization, thermal energy network, district heating, and let's bring some energy efficiency to the future.
Wonderful. Awesome. Thanks so much, folks. Really appreciate it.
Thank you,
Thank you,
Justin.
Justin.